Hello everyone, welcome to my channel. This is an educational channel focused on getting you up to speed on some of the great theories of everything that are out there that I've uncovered, usually accidentally, in my years of research. And today is video number 357 on Dewey B. Larson and his reciprocal system of theory. Larson lived back in the 20th century, and around 1959 he proposed his two fundamental postulates. And after that he took his two postulates and went through a process of deduction and came up with a theoretical universe of how the universe would look if his two postulates were correct. And then he spent some time writing books and more or less comparing his theoretical universe with the universe at large that was observed and hypothesized by legacy science. And very interesting study. Larson died back in 1990, leaving behind a dozen or so books, maybe a little bit more than that. I haven't counted. About 50 articles, a lot of talks, a lot of other ephemera, and a handful of an organization, a journal, and a handful of other researchers who were keen to put their contributions in on the reciprocal system. And we're going to be hearing from one of those people today, Dr. Bruce Peret, who came up with this thing called RS2, Reciprocal System 2, along with Dr. KVK Nehru. And that is the re-evaluation of the reciprocal system. He has about 9 articles here that are called RS2, 101, 102, 103. We're on number 107 today, which is called Mass and Gravity. And so we're going to look into Dr. Peret's evaluation of at least mass and gravity in terms of the reciprocal system. Now, the basic idea behind the reciprocal system is that we live in a universe that is made out of motion. And it's not made out of matter, not made out of energy. It's not even made out of any fundamental forces. But it's made out, in fact, all 3 of those things are merely different varieties of motion, as are all of our scientific quantities are expressions of motion and can be expressed exclusively in terms of space and time, because that is how Larson defines motion. Motion is the relationship between space and time. Motion for Larson is basically a fraction with time or space as the numerator, space or time as the denominator, such as speed. Speed is space over time. The bicycle is moving 10 miles per hour. 10 miles of space in 1 hour of time. And you can see the reciprocal relationship between space and time there in speed. Say if you want to double the speed. If you double the speed, you can say the bicycle is moving 20 miles per hour. You're doubling the space and keeping the time the same. But you can also say that the bicycle is moving 10 miles per half hour. So you can half the time. It's the same as doubling the space. There is a reciprocal relationship between time and space. That's why Larson calls it the reciprocal system of theory, because of this reciprocal relationship between time and space in motion. Time and space are reciprocals of each other, and as a result, just like all other reciprocals, they have the same symmetrical qualities. What we know best about space is that it is three-dimensional. X, Y, Z coordinates. I will just say multi-dimensional. I think it also can be four-dimensional, but Larson goes with three-dimensional, X, Y, Z coordinates, and as a result, time is also three-dimensional. And Larson refers to this as coordinate time, coordinate space and coordinate time. Then also, time and space both progress. Larson refers to this as clock time and clock space. Now, this progression is important because this is the fundamental motion that the universe is made out of. The coordinate time and coordinate space is somewhat of an illusion that has to do with really being in a gravitational field. It appears when you have this coordinate time or coordinate space, you have stationary space or stationary time. But in a universe of motion, the real aspect is the progression of space and the progression of time. Clock space and clock time. The clock is always getting later and later and later and later. And in space, that means that space is always getting farther and farther and farther apart. But in both cases, neither space nor time is moving in any particular direction. This is what is known as scalar motion. Larson calls it scalar motion, and scalar motion is a kind of motion that has been noticed and documented by other researchers, but they have never really seen scalar motion to be of any importance and have never given it any type of centrality to their theories, unlike Larson. Now, a scalar motion is a motion that has a magnitude, but it has no specific direction. The clock is always getting later and later and later, but it's not getting later in any specific direction. And time is, the space is always getting farther and farther and farther apart. Also not getting farther apart in any particular direction. You can envision this using a balloon with dots on it. If you blow up the balloon, all of the dots are moving away from each other. And that is a scalar motion. The farther away the dots are, the faster they're moving away from each other. And you are not able to actually notice any type of direction or specific direction. Each dot is moving away from each other dot. And in fact, the spaces between the dots are also moving away from the other dots and the other spaces between the dots. All points on the balloon, all locations on the balloon are moving away from each other. So it's no specific direction, really every direction. The only way that you get any type of directionality out of this is when you arbitrarily decide that one of the dots or one of the locations is motionless. When you that would be what you would call a reference point. When you arbitrarily decide that one of these points is motionless, then you can start to determine directions to the other dots. Now, this was also recognized by the astronomers who, looking through their telescopes, noticed that all of the distant galaxies are moving away from each other. But still, they didn't recognize this was a significant kind of motion. Instead, they decided that this was the argument for the Big Bang, and that the Big Bang meant that at one point in time, all of these different dots, all these different galaxies were located in a singularity, all jammed together, and then that whole thing blew up. And that's why all the galaxies are moving away from each other, because they are the product of this huge bang that occurred 13 billion years ago, or whatever it is. And so that is jumping to conclusions, but this is actually a scalar motion, and it is a product of a universe of motion. And now the other part that Larson includes in his first postulate about space and time is that they both come in discrete units. There's a minimum unit of space and a minimum unit of time. If you don't have a full unit of space or time, then you don't have any space or time. You have to have a full unit. And if you have 1 unit of space in 1 unit of time, you have the speed of light. Space over time is speed. 1 unit of space and 1 unit of time is the speed of light. Larson refers to this as unit speed. 1 over 1 equals 1. This is the place where space equals time. They both equal 1. And this is really what Larson refers to as the null point, or the state of rest, or the 0 point, or the origin, the ether of this universe of motion, is the speed of light moving outward in all directions, in both space and time. And Larson refers to this as the progression of the natural reference system. So this progressing is kind of the nature of this universe. This contrasts sharply with the legacy scientists who say that the speed of light is the maximum speed of the universe and that nothing can go faster than the speed of light. Larson is saying that the speed of light is the midpoint of the universe, the neutral point, and that half of the universe is actually moving faster than the speed of light, which he refers to as the cosmic sector, and that there's half of the universe that's moving slower than the speed of light, the material sector. And the material sector is really the only sector that the legacy scientists know about. And that's where they make their measurements. That's where we all make our measurements. That's where we reside. And that's, but because of the reciprocal relationship between space and time, we can determine what's going on in the cosmic sector. All we have to do is invert the roles of space and time. So in the material sector, we're accustomed to the idea of coordinate space, 3 dimensions of space, stationary space, and clock time. The clock is always getting later and later and later. In the cosmic sector, once we cross that unit speed boundary, we move into the cosmic sector and observe coordinate time, 3 dimensions of stationary time. and clock space. Space is always getting farther and farther and farther apart, like on the surface of an expanding balloon. So that is how that reciprocity works out. And now there's a second postulate also, which basically says that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute and its geometry is Euclidean. This postulate has been actually rejected by Dr. Bruce Peret, for one. Not entirely rejected, but he gets rid of the idea of the commutative mathematics. He gets rid of the idea of the primary magnitudes, and he gets rid of the idea of the Euclidean geometry to replace it with projective geometry, which is a kind of geometry that includes a Euclidean geometry. Okay, now let's start up with Dr. Peret's paper here. Now, we went through the beginning of this paper yesterday, so this is the second installment. So if you want to go from the start, go back to yesterday's episode and listen to the second half of the episode. Okay, this section is called Gravity of the Situation. As we know, space and time are reciprocals of each other. In the reciprocal system, everything has its reciprocal, which also includes direction, velocity, and geometry. Inward and outward motion are reciprocals, as are linear and angular velocities, and points and volumes. So this is something that Larson didn't really get into. The reciprocity, especially the geometrical reciprocity, and also the linear and angular velocities being also reciprocals of one another. So we have mass defined as an outward angular velocity in time, defining a volume. Let's take a complete reciprocal of mass and see what we have as a natural consequence. The aspect of time becomes space. Outward motion becomes inward motion. Angular or circumferential velocity, basically like rotation, becomes linear or radial velocity, which is like the radius of the circle. So, you have the radius and you have the circumference. The radial motion is linear. The circumferential motion is angular or circular. I suppose it might also be elliptical. I'm not sure about that. Okay, volume becomes a point location. These are the reciprocities, volume and a point, three-dimensional and zero-dimensional. The reciprocal of mass is therefore an inward linear velocity in space that can be expressed through a single point. That is the definition of gravity. An inward linear velocity in space that can be expressed through a single point. Definition of gravity where the point is the center of gravity. Mass and gravity are the same thing from inverse perspectives. Yeah, I have trouble with that concept. That doesn't mean it's wrong. It just means that I'm slow to grasp that. But because I'm under the impression that gravity is like the sucking in of the balloon. When you move the, if you have the balloon with dots on it, you blow it up and all the points move away from each other. That's what you call the progression. But when you take the balloon and you suck in the balloon and all the points start moving toward each other, that's what I thought was gravity, and that doesn't really have anything to do with a reference point. You still need to have a reference point before you can have any type of center of gravity. So I'm a little bit lost about that. Okay, so this section is called massless particles. All material motions have a rotation in time, and therefore all material motions, particles and atoms, must have mass. The problem with massless particles lies in the way we indirectly measure mass through the measurable gravitational pull in space, not unmeasurable angular velocity in time. And that brings up another reciprocal relation, that of the inverse relationship between step measure, how we measure things in a straight line, and growth measure, which is how we measure angles. Step measure is the conventional method of measuring finite quantities, just like pacing off steps to measure distance. This is associated with the first unit of motion, speed, with the range of 0 to 1. Coordinate time can also be step measured. But unfortunately, our mechanics and technology only allow us to measure space, not time. We can only see space, not time. So temporal measurements must be made by their projection into equivalent space as an angular change or growth measure. Growth measure is associated with the second unit of motion, energy, with the range of 1 to infinity. So as far as I know, this is really talking about like a cosmic sector kind of thing. This is, the mass or the speed aspect goes from 0 to 1, 1 being the boundary, the unit speed boundary, and then energy goes from 1 to infinity, the greater than 1. But I could be wrong about that, so let's keep going. Since we cannot do a finite count to infinity, growth measure is done with the calculus concept of infinitesimals, the integral. To transform this growth measure in equivalent space to a step measure in linear space, the natural logarithm must be used as the log of delta t. The consequence of this is that the magnitude of gravity appears as a logarithmic curve, whereas the magnitude of mass is linear. The reciprocal system works with discrete units, quanta. So until the magnitude of a temporal rotation becomes mass, no. until the magnitude of a temporal rotation mass becomes high enough to produce a single unit of inward spatial magnitude, gravity does not exist in space. Yeah, okay. And that occurs with a net temporal speed of 3. Displacement units, since the log of 3 is greater than 1. If you have a log of 2, that's less than 1, and the log of 1 is 0. So you have to have a full 3 units before your log is 1 or greater, enough for a discrete unit of space, of time. So any rotating system that has a net displacement of 0, 1, or 2 will have no effect as gravity in space, giving them the appearance of being massless. Specifically, the massless particles are photons, positrons, electrons, and neutrinos. The proton is the first particle with mass, having a temporal displacement of 3 units. 2 for the proton plus 1 for the rotational base. The electron volt masses that are associated with these massless particles are an attempt to determine the actual rotational speeds of the particles rather than inferring it from their gravitational influence. Okay, that's the end of that section. We will stop it off there and move into this next section tomorrow, which is called particles moving at the speed of light. So we're going to look at some more about these massless particles. The basic idea, I think, is just that in Larson's notation, atoms and particles are rotational motions. And they come in 3 different, you can have a 2-dimensional primary rotation, a 2-dimensional secondary rotation, and a 1-dimensional rotation. And you need to have a total of 3 of those, well, actually 2, plus the rotational base, in order to create mass, because mass requires a discrete unit. And he talked about a lot of other stuff there. Sometimes Peret overloads you with concepts, and sometimes he doesn't flesh those out particularly well. I'm not sure why he even got into talking about these inverses. The inverse of volume is a point, and the inverse of or the reciprocal of velocity, and the reciprocal of linear velocity is angular velocity. And it can be a little bit overwhelming and confusing. Again, my advice is just to let it wash over you, and take what you need, leave the rest, but leave it in your head so that you might be able to get it later. And don't reject anything out of hand. Give Larson the opportunity, or give the reciprocal system the opportunity to state their case. And the case cannot be stated in like one episode of this. You need to have a holistic picture of the reciprocal system, which requires a number of different repetitions. The reciprocal system is very multifaceted, and it goes into every subject. And so if you just kind of learn one subject, you're not getting the full picture. It's much more powerful to understand that the reciprocal system uses the same rules regardless of the subject. And so it's using the same equations in many cases, if you're looking at atomic physics or if you're looking at astrophysics. It uses the same basic equations and the same concepts to deal with atoms as it does dealing with galaxies. And so it's powerful to see the consistency involved, whereas legacy science is using fragments. They have one theory for the atom, and they have another theory for, macro things, and then an entirely other theory for astronomical things. But Larson is using the same concepts for everything. And so you have to kind of stick with it until you see the whole picture. Okay, thanks for tuning in today. We'll be back tomorrow to continue this article on mass and gravity.